Hi, my name is Scott Renner, and I'm a second-year biomedical engineering major here at Tech, and this is my extra credit talk on physics lectures throughout the year. I went to 3 lectures. The first one was by Stephen Morris, PhD, on pattern formation in nature, the universe is not boring. The second one, David Lentic, on bio-inspired design, discussing the aerodynamics of bird flight and applying it to robotics. And third one was what happened before the Big Bang. A very technical lecture that I didn't understand much, but still could take some general principles from it. First lecture, Stephen Morris on pattern formation, was really interesting. Probably one of my two favorite lectures. And first off, he talked about systems and entropy. And I really like this. He talked about how something in a closed system will reach equilibrium, but something in an open system will be dynamic and never really reach equilibrium and have entropy. And it's really cool talking about how the entropy in life and it's like the beauty of life of how entropy always increases and disorder always increases, and it speaks a lot about the world and about nature and kind of leading up to everything he's talking about. And the next major point he made was about nature, about stability, not optimality. And the river example is great, and I really like this. And he said nature, people think that the best species evolve, and people think that everything moves towards optimality and evolution in nature, but it's actually towards stability, which isn't intuitive but makes a lot of sense when he presents it. And his was the river example and erosion, and how it's not an optimal path for the river, but it's whatever is most stable for the overall environment. And again, with these talks, I'm really into design and applying physics principles to design and just design in general. And it's cool. A lot of these talks you can apply just the general principles to design. He went through a lot of examples about the patterns in natures that seem standard but aren't intuitively derived. And he talked about ripples, beach cuffs, dunes, and how those patterns are formed. And then his major experiment, which went on for a while, and some examples relating to that, was the mask experiment, and the 2 different grains that were used, and how the smaller grains would end up at the bottom, the larger grains would end up in the middle, in nearly perfect pattern as the total pattern progressed. And because the smaller ones could sieve their way through the bottom. And that was a really interesting experiment that I did not expect the results of, and I was really amazed when I saw that, and it sparked a lot of curiosity into what certain unintuitive patterns like that could be applied to certain algorithms and designs and certain biomedical settings. And near the top of the thing, it reached a nearly perfect segregation effect once it kind of stabilized. And then they showed so many examples of that, even in a tube segregation forms vertically or axially inside of the tube. And he did some examples on heat, chemical mixtures, and how the heat applied to them would increasingly create a chaotic pattern, yet was still a pattern even though it's chaotic. And I really liked a lot of this stuff just because it could teach you a lot about applying to design stability versus optimality, and sometimes you don't want optimality. Depending on what you're looking at, you might want stability, not optimality. And always just considering that your type of system, an open system, that the entropy always increases, is just an amazing fact, and just so simple yet so profound. And those are some of the most important things I got from this talk. My second favorite talk was definitely this. The first or the second were my favorite. Bio-inspired design. Obviously, as a biomedical bioengineer type person, I appreciate a lot what was going on with this design and a lot what I could implement into my own design. Definitely my favorite lecture by Lentic. And definitely similar to last lecture and some of the things that I could apply. He talked a lot about bird flight and aerodynamics of bird flight, and how he was using a period time and speed rate of the wings, and incorporating that into robotics birds into other systems that are similar to flight. And I really like this because sometimes finding optimal rates for things is non-intuitive, and you can't just come up with a optimal rate necessarily in an easy way. And using nature and organisms, you can use their rates as he suggested, and then work off making their rates even more efficient, or just analyzing how efficient their rates are and what can be improved in the actual bird itself. Certain natural algorithms could be used to optimize systems, as he suggested, and just a lot of things for robotics. I mean, it was a lot about birds, and I just really liked the fact that you could use all the different kind of cyclical rates with their flight and apply them into from bumblebees or from large-scale flying birds or wing length, and apply it to all types of robotics and planes even. And he had a few interesting plane designs too, from like bird, the nature of the bird and the data collected from the bird. And some of the data was quite surprising too. And that was my second lecture I went to, is Bio-Inspired Design, one of my favorites. And then the third lecture I went to was What Happened Before the Big Bang. And this lecture was very technical, and a few minutes through I wasn't following much, but occasionally I would understand the general principles and occasionally pick up a few technical things that I could relate with. And it was really cool. Just generally the physics that I understood it was cool seeing some general, very simple kinematic equations being used to predict astronomical like movement and astronomical results of the Big Bang. And I also like this on a curiosity and like philosophical level of this talk, because I've always like wondered, what happened before the Big Bang, and I didn't even know that people were this far in talking about the mathematics and kinematics of what actually happened before, and calculating what happened before, the energy involved, and the initial velocities even spurring tons of bodies in space. And I even remember, I'm pretty sure I saw simple equations such as like v equals change in distance over time being implemented at the initial moment of the Big Bang, and even momentum principle, and some basic principles that you wouldn't expect moved a long way in analyzing the Big Bang. And it shows you how these simple fundamental principles that we learned, just purely energy and all these talks, energy and momentum, those two principles can be applied to the majority of things that we at least perceive with our eyes in everyday life and astronomical life. But those are my three talks, and I learned a lot of these, and the first and second were definitely my favorite, and I'm looking a lot more into bio-inspired design and just the interest in pattern formation in nature. I even looked at that book that he suggested, and yeah, they're good talks, and definitely enjoyed them. Thanks.